Hey everybody, we are continuing the pre-calculus video. So this is on 7.3 trig equations. And so here we have secant 3 theta over 2 equal negative 2. So remember, like we said before, if you want to graph F1 to be secant, on our Inspire calculators, how you do that is you go to graph, go to the trig button, and you can choose secant. Not all calculators have that. You might have to do 1 over cosine instead. But here we have secant, and instead of actually putting theta, we put x. So 3x over 2, and then we want where it's negative 2. So I'm hit tab and hit negative 2 here. And so we want those spots. So this is why I said don't just do minimum or maximum. You know, in this case, I need negative 2. And our interval is going to still be 0 to 2 pi. And so we can double click here, put 0. Or if you don't like that, then go to menu, 4 for window, 1 for settings. You can see I just changed that to 0 and it remembered it. And then here I want to put 2 pi. So remember the pi button is next to the H. And we want pi. Okay, so here I see I'm going to have 1, 2, 3 answers. If nothing else, you might just want to graph it and to see how many answers you're supposed to get. Graph to see if 3 or 4 answers. In this case, there are going to be 3. Now, the first one, if I go to the intersection between here and here, I'm going to start seeing some numbers that I'm not used to. So you may just do this as a way to check it. 1.396. Got to move that. $2.7925. I am just taking the x answers because the y answer would be negative 2. Lower bound means the left side. And remember, if it's an open hand, you can push down, grab it, see it closed, and then move it. And that's your 5.85, or whatever it is, 5.585. Now, these are all just rounded values. It doesn't let you convert that to a square root. It doesn't let you convert that to a pi. Those are just our estimates. That would be counted wrong, but those are our estimates. So that's what we're shooting towards to see if you're right or not. Okay, so how do we solve this? We first say the problem was secant 3 theta over 2 equal negative 2. Well, if we do inverse secant, then we get 3 theta over 2 is inverse secant of negative 2. Now, what does that mean? Well, it has to do with where cosine inverse would be negative 1/2. I think on the calculator, if you just do inverse secant of negative 2, okay, on the teacher calculator, it gives me the answer. So if I do yours and put it in decimal mode, I see 2.094. secant -1 of -2 is 2.094. Now, you already saw it because I'm using the teacher calculator. That is 2 pi thirds. Remember, there are some decimals that you might want to start being able to guess and check and get it. If not, let's keep on working. Now, just for understanding purposes, what happened at 2 pi thirds? Well, at 2 pi thirds, it was -1/2 and square root of 3 over 2. Well, that means that cosine of 2 pi thirds was -1/2, which meant secant of 2 pi thirds is -2. And so remember, you flip your cosine to become secant, flip your -1/2 to become -2. And so that'd be the way to really get it. Because, you know, if you have -2 and you flip it, it's going to be -1/2. And if it's secant, it's going to relate to cosine. Okay, so we have 3 theta over 2 equal to, let's see, 2 pi thirds. So then we're solving for theta, so we multiply by 2, and so we get 3 theta equal 4 pi thirds. And then we divide by 3 or multiply by 1/3, and that gives you 4 pi ninths. And so that is the first one. Okay, so that's how you get that for the first one. Now, remember earlier we said, well, what was our period? Our normal period, I guess that's right here, is 2 pi, but the period would be the normal period divided by W. Remember we did this on a previous lesson? It's going to be helpful here because I think guessing and checking is going to be harder. So we'd say period is the normal period divided by W. The normal period is 2 pi. Our W is this 3 halves. And so then this becomes 4 pi over 3. Well, 4 pi over 9 plus 4 thirds is a bit weird. What if you made that a 9? For a denominator, to get a common denominator, you would have to multiply the top and the bottom by 3. So times 3 over 3, which would be 4 pi over 9 plus 12 pi over 9. And 4 plus 12 is 16. So there's 16 pi over 9, which is one of them. So there's 2 of the answers. Now the third one, just saying the truth, I mean, you might have to just say, well, 9 pi ninths would be pi, which is 3.14, and all these others had a denominator of 9, so you could say try 7 pi over 9, 8 pi over 9, because we wanted something smaller than 3.14. So 7 pi over 9 is, survey says, 2.443. 8 pi over 9 is 2.7925. And that is what we want. So I know this isn't easy, but sometimes you got to use multiple techniques. Like right there, I got these two pretty easily, but then this one I had to do a guess and check. Let me think for a second. Okay, so I said guess and check for the last. Well, what if we didn't just guess and check? Okay, so instead, let's say, well, is there another place on the unit circle where cosine is negative a half? Is there another place on the unit circle where cosine is negative a half? Because remember here, we figured out that if secant was -2, cosine had to be negative a half. So can't we just do this on the unit circle? Yes. So look where x equal negative a half. Well, negative a half is right here at 2 pi thirds, but it's also here at 4 pi thirds. So at 4 pi thirds, the ordered pair is negative a half, negative square root of 3 over 2. And so basically our theta could be 4 pi thirds. Well, we have an equation over here, 3 theta equal that, or actually 3 theta over 2. So if 3 theta over 2 equal 4 pi thirds multiplied by 2, so you get 3 theta equal 8 pi over 3, and then divide by 3 or multiply by a third, and so theta would be 8 pi over 9. So there I've shown you the exact way. And here's the guess and check. So I really did show you both ways to do it. Some people are going to prefer guess and check. Some people are going to prefer getting the exact answer. So do whatever is best for you. Remember, in the interest of time, you may just want to do it the exact way. Okay, moving on to number 6. This one says square root of 3 cotangent is plus 1 is equal to 0. What that means is square root of 3 cotan theta plus 1 equals 0. So square root of 3 cotan theta equal -1. So cotan theta is -1 over square root of 3. And again, magic, not really. Cotan is the same as 1 over tan. Tan is 1 over cotan. So what if we just change this to say, do the reciprocal? Well, tan would be when this is flipped, so negative square root of 3. And we've done these before where you said tan is y over x. And so that means, like, in our case on the unit circle, it's got to be negative square root of 3 over 2 over a half. So your 2's cancel and you get negative square root of 3. That's one place. So we're looking for where it's a half common negative square root of 3 over 2, or where it's negative a half and positive square root of 3 over 2. Okay. So then if we're looking for where x is positive and y is negative, X is positive, Y is negative. That's at 5 pi thirds. And this is where X is negative and Y is positive. And that's at 2 pi thirds. And then they just ordered it at least to greatest. I don't know if you have to do that or not, but there they are. Okay. So then for this one, we have cosine of this expression with a horizontal shift of pi halves. You got a 2 in front also. Okay, so for this one, we want to do inverse cosine of both sides. So we have 2 theta minus pi halves equal inverse cosine of 1. Well, inverse cosine of 1 means where is x equal to 1? It's just there at 0. Zero degrees or 0 radians. So what if we just said 2 theta minus pi halves equals 0? That means 2 theta equal pi halves because we're adding pi halves to both sides. And now we're going to divide by 2 or multiply by a half. And so we get pi fourths. So there we go. And like we said before, if you want to get the other answer by guessing and checking, you can. I would say, well, our period is the normal period divided by W. So that'd be 2 pi divided by 2, which is pi. What is pi fourths plus pi? Well, that's the same as saying pi fourths plus 4 pi fourths. And so that's 5 pi fourths. So even though you're in this 0 to 2 pi thing, you're not just going to get one answer. If you graph it, you might get 2, you might get 3, and you see how I'm doing it even without the calculator. Use your formulas. Period is the normal period divided by W. Okay. Now for this one, we want cosine theta is square root of 3 over 2. That means where is theta when x equal square root of 3 over 2? Well, it's going to be in 2 spots. If you remember from when we memorized the unit circle, it'd be a half and negative a half. Because the square root of 3 goes with the 1. So that happened at pi 6. And we went for negative a half, which is 11 pi 6. Now remember in the notes where I said smaller? Well, this is definitely the smaller because pi 6 is smaller than 11 pi 6. Pi 6, 11 pi 6. Now this is the other part. It says the general form. Do not overlook that. That means you have to use k. And so I'd say it'd probably let you do pi 6 plus 2 pi k, or say pi 6 plus 2k pi. The order of the multiplying doesn't matter. I don't know on Math Excel whether it needs the k right there. It probably doesn't, but test it out. I mean, you'll have extra checks, so check it out. If this answer that's printed has the k, you probably want to put the k first. But to me, logically, it makes more sense, like how many times around 2 pi? So that's my thought. So then here's your 11 pi 6 plus 2k pi. Now, when it's saying list the solutions for k equals 0, 1, and 2, that means, let's just do this. And do this one as a table. We want when it's 0. Well, that's easy. Those are your first two answers. So that's if k equals 0. Now, if k equal 1, that means pi 6 plus 2 times 1 pi, or just say pi 6 plus 2 pi. Here, you're going to want to get a common denominator. Of 6, and so that's pi 6 plus 12 pi 6, and so you get 13 pi 6. And for this other end, if we have 11 pi 6 plus 2 pi, that'd be 11 pi 6 plus 12 pi 6, which is 23 pi 6. And so that's your next two. Now, for those that don't like doing common denominators, you could do 1 6 plus 2 on the calculator. Forget the pi. 1 6 plus 2 is 13 6. And then write 13 pi 6. And 11 6 plus 2 is 23, so 23 pi 6. So again, you can do it that way if you want. It's pretty handy that the calculator converts to make the improper fraction. Okay, so those are two of our answers. So that's if k is 1. So we've covered when k is 0, k is 1. Again, if you want to start catching a pattern, 1, because like 1 pi, 1 plus 12 is 13. 13 plus 12 is 25. Guess what? There we go. And 11 plus 12 is 23. 23 plus 12 is 35. There we go. So take your time. You got to get used to these by doing your own. But yeah, work through it. That's basically what we did. When you get a common denominator, your denominator itself doesn't change because you only do the numerator plus the numerator. So your denominator would stay the same. And so throughout all of these, your denominator stayed 6. So that's how you can think of that. The denominator stayed 6 throughout. Okay, take your notes. Okay, on this one we have cosine is negative square root of 2 over 2. Well, that means where is x equal to negative square root of 2 over 2? Well, that's right here at 3 pi fourths and right there at 5 pi fourths. Three pi fourths is smaller, 5 pi fourths is bigger, and then we just loop around, plus 2 pi k. Okay, so as you do more of these, you're going to get better. So there's our first two, 3 pi 4s and 5 pi 4s. Now, did we have a value of W, or let's just say what is W? Here W is 1. So that means our period would be 2 pi. Now, what is 2 when we have a denominator of 4? 2 pi is the same thing as 8 pi over 4. And so here we can say 3 plus 8 over 4 is 11 fourths. So I'm going to put 11 pi over 4. I mean, if you just want to use your numerators, 11 plus 8 is 19. So there's 19 pi over 4. So these are add 8 each time. And guess what? These are also add 8 each time. 5 plus 8 is 13. So it's 13 pi fourths. 13 plus 8 is 21. So it's 21 pi fourths. I'm sure on view an example, it's going to show you a longer method. Like some of these may say 20 steps. I don't know. But I know this way works. Last thing I'll say before I move on to the next problem is, well, what if we graphed it? Graphing is not always the best method, as you've seen. But what if you graphed it? Cosine x is 8. I'm sorry, what did I say? F1 is cosine. F2 is negative square root of 2 over 2. So there, and we want the general at first, so you can't use your calculator for these, but on these it says, what are the first 6 answers? What are the first 6 answers? So, and again, on our window, we want 0 to 2 pi. So x min 0, x max 2 pi, and you want the first 6 answers. Okay, so if I change my window settings to 0 to 2 pi, okay, there I only see 2 answers. But then when we expand this, we want when k was 1 and 2. So if k were 2, we'd probably want this to be 8 pi. And so there you see 1, 2, 3, 4, 5, 6. I guess I did too much, 7, 8. We just want the first 6. I guess we could say, so change to 6 pi, not 8 pi. So if we change the window to 6 pi, we're going to see 1, 2, 3, 4, 5, 6 answers. That makes sense. Okay, but again, it's going to look weird with all the decimals. That's 2.356. That's 3.92, and so forth. Now notice the square root of 2 over 2 is 0.707. In this case, we have negative square root of 2 over 2, so that's why it's a negative 0.707. But again, there you go. Now, we have some easier problems. Yay. Okay, so on this one, we go to secant x, and we put negative 5.8. Okay, well, there you go. We want it on the interval 0 to 2 pi. So there's your two answers. And this time they really do want you to round. 1.744. So round down. And then five 4.539, and so round up. They just want 2 decimal places. Okay, on this one we also want 2 decimal places. Let's see. Since my window is set, I'm just going to change F1 and F2. And change F2 to just be 0. And change F1 to be 7 tan x, and then plus 8. So you got to go to the right and then go plus 8. Okay, so there's our answer. The first one showed up for me. It's 2.289. So round down. Menu. Analyze. You could either do 0 of the graph or do intersect. .431. So round down. That's the down arrow is the shortcut for round down. Pretty obvious, but want to make sure you're on the same page as me. Okay, so there you go. Here we're doing a quadratic. Actually, let's see, we have 6 problems left. Let's stop right there for this video.